So this lesson's on the unit normal vector. So we need to talk about what that represents. But let's remind ourselves of what the unit tangent vector is. Big T of t is in the same direction as the velocity, but it has length 1, so it's velocity divided by speed. So the key idea here is that the magnitude of T of t equals 1. That's going to be important for us in our analysis. We know, of course, that T of t dot T of t is the same thing as the magnitude of T of t squared, which would be 1 squared, which would be 1. So this is an important fact. So T of t dot T of t is 1. And we want to think about something that is going to be orthogonal to that. And recall that two vectors are orthogonal if the dot product is 0. So how does that help me? How can I get there? Well, what I'm going to do here is I'm going to take the derivative with respect to t of both sides. The derivative with respect to t of t dot T of t is going to equal the derivative with respect to t of 1. Now, the derivative of a dot product works exactly the way that you would want it to work. Namely, it behaves like the product rule from calculus 1. So the derivative of the first, t prime of t dot T of t plus t of t dot T prime of t is going to equal what? Equal the derivative of 1, which is 0. Now, what else do we know? At least in this course, the dot product is always commutative. When you get to more advanced courses in algebra, inner products aren't necessarily commutative, but in this case they are. So t prime dot t and t dot T prime are the same thing. So I can think of this as twice t prime of t dot T of t equals 0, which will tell me then that t prime of t dot T of t is 0. But if I have two vectors and the dot product is 0, what can we conclude? Two vectors and the dot product is 0. What do we conclude? We conclude that those two vectors are orthogonal. So t prime of t is perpendicular to T of t. And this is going to help us define the unit normal vector. But the magnitude of t prime of t doesn't necessarily have to equal 1. So what do we say about that? So we know that t prime of t is orthogonal to T of t. We just proved that. We also know that the magnitude of t prime of t does not have to equal 1. But we want the unit normal vector. So how are we going to define the unit normal vector? N of t is going to be called the unit normal vector. It is orthogonal to the curve. It is perpendicular to T of t. And the unit normal vector simply will be t prime of t divided by the magnitude of t prime of t. Now, this is a little tricky to think about because there are an infinite number of vectors that would be orthogonal to a given vector. So if this is my curve R of t, and this is T of t, where is N of t? Well, if we're working in 2 dimensions, you have 2 choices. You have one going this way with length 1, or one going the other way with length 1. So one fact that we have is that N of t always points toward the concave side of the curve. So we need to keep that in mind. What else do we need to keep in mind? Well, We know that big T is in the same direction as V. So V of T and A of T, the acceleration, lie in a plane. Two vectors define a plane. You could get as normal vector by taking the cross product. Big T of T is in the same direction as V of T. Big N of T, not typically in the same direction of A of T, but T of T and N of T lie in the same plane. As the velocity and the acceleration. So that is something else for us to think about. So big N points towards the concave side, the center of curvature. If you would draw a tangent circle to this point, its center is in the direction of N. So you have the concave side, N points towards the concave side, and N is in the same plane as the acceleration, but we do not expect big N and the acceleration to be in the same direction necessarily. So let's look at this example with the goal of finding both big T of T and big N of T. We start by finding the velocity, which is going to be -3 sine T, 3 cos T, 4. And we're going to find the speed. Is going to be square root of 9 sine squared T plus 9 cos squared T plus 16. That's 9 plus 16. That's root 25, which is 5. So big T of T is velocity divided by speed. So divide all those things by 5, and I get -3/5 sine T, 3/5 cos T, and 4/5. Now, what about N? What did we say N of T was? We said N of T was T prime of T divided by the magnitude of T prime of T. So what is T prime of T? -3/5 cos T, -3/5 sine T, 0. Interesting. So notice T prime of T has no component in the Z direction. So it lives completely in a plane parallel to the XY plane. That's what our concept is there. Then what do we want to find? We want to find the magnitude of T prime of T, which will be what? Square root of 9/25 cos squared T plus 9/25 sine squared T plus 0. So the magnitude of T prime of T is the square root of 9/25, which equals 3/5. So now to get N of T again, we see over here N of T is T of T divided by the T prime of T divided by the magnitude of T prime of T. So we take our T prime of T, which is -3/5 cos T, -3/5 sine T, 0, all divided by 3/5. So then what does that give me for N of T? So N of T is simply negative cos T, negative sine T, 0.